is soils. We've got Jim Turini, who is the state soil scientist. Jillian Connolly, who works for NRCS, former Envirothon student as well. Graduated from URI in geosciences, so she's got a really good background. She's gone through the Envirothon program, went to Nationals in 2009.
In 2008, 2007.
So we went.
What was that? What was that held?
2007 was New York State, 2008 was Arizona, and 2009 was North Carolina. So
And this year's Missouri.
this year's in Missouri.
Missouri.
And, Eric's team, the last time it was in Missouri. Yep, 2005. So
Missouri or Missouri?
yeah, whichever one you want. Depends on where you are located in the country.
Gotcha.
It's like Rhode Island or Rhode Island.
All right.
Okay?
Cool.
So,
All right.
Mr. Turini.
Yeah. All right. So how many people have already been here and are returning? Just need a show of hands. Wow. So pretty much everybody's new on this. So, okay. What we're going to do is kind of quickly go through looking at some soil profiles. I'll show you what I see when I look at a soil. I want to kind of quickly go through the next PowerPoint, which is just an overview of the soils of Rhode Island, and then focus on, we're going to take you out, and I got a couple of pits dug outside. Jillian's going to show you how to do slope, measure slopes, and then we'll look at some soils. I want you to practice doing describing a soil, looking at the horizons, color, and texture, kind of the three main things we do when we describe a soil. And then we're going to walk down and look at a wetland soil, and we'll have everybody out, no problem, by 12 o'clock. So I'm going to go kind of fast. If anybody needs something clarified, just raise your hand and let me know. What I recommend doing is all of this stuff is available online. It should be on the Rhode Island Envirothon website. When you get home and you feel like looking at some slides, do a lot of homework on, refreshing yourself on soils. And then if you have any questions, just call me or Jillian there. All right, let me get this thing set up. All right, just wanted to show again a few soil profiles. So this is a, yeah, if you can. Yeah, this projector is not the best in the world. But what a soil scientist is able to do is basically look at a slice, what we call a soil profile, and we describe it. As with any science, we classify it. We have a system of soil classifying soils called soil taxonomy, which probably won't get into. And then we look at the morphology, or what we see by looking at the profile, and then from that we can make interpretations about what is this soil suited for, what are some of the properties, chemical, physical, is it well suited for trees, does it have high water tables, can you grow, what type of trees will grow on it. We have over about 50 different what we call soil interpretations that we make and are available in a soil survey. So very important if you're ever buying property, looking at land, wanting to grow something, is to consult the soils first. A lot of people, when they're looking for a house or something, they're looking at the community, how good are the schools. When you actually buy the house, you want to take a look at your soils because it can make a difference as far as costs and whether or not your basement's going to flood and stuff like that. So on this soil here, I get this nice dark topsoil. That's an A horizon. We're going to talk a little bit more about that. Below is the subsoil. We call those B horizons. And then below that is your parent material, or the geologic material the soil formed in. And then I'm looking at that lower part there, and I'm seeing these blotchy colors in the soil. We call those redoxymorphic features, and that's indicative of a seasonal high water table, which comes up on this soil. So even though the soil is high and dry right now, at some time of the year, I can say that this thing has a water table about 40 centimeters below the surface. So again, if you got a house with a foundation on here, you're going to have a wet basement on this soil. It's quite wet. This soil here, again, has a nice plow layer. Anytime you see that thick surface, which we'll go into what these horizons mean later on, that's telling me it's been plowed. I have that nice yellowish brown subsoil material. That's telling me the soil is well aerated. Iron oxide is coating the sand, silt, and clay particles, and you only get iron oxide in well aerated soils. And then below that, if I were to dig in here, I'd notice that there's a very difficult, hard, restrictive layer to dig through. And that's called glacial till material, which is what we're sitting on right here. And again, this soil has a water table 60 centimeters below the surface. This is a nice forested area. This would be out in Wild Standish, where you get pitch pine and scrub oak out there. And again, in wooded areas, you typically have a nice organic layer in the soil on the surface. And when I dig down and I actually hit the mineral soil material here, I can see just a very thin A horizon. Tells me the soil has never been plowed. So this is a nice natural soil that's never been farmed ever in history there. If you're out in Little Compton, if you ever go to, pretty much when you go over heading over at the Jamestown Bridge, you'll notice that the rocks there all look different. They're all black and stratified rocks, and that's because you're in what's called the Narragansett Basin, which is a carboniferous basin, and the rocks are all shale, high in carbon, and when you look at the soils there, the soils all tend to be black because of the type of bedrock that the soil's formed in there. So that's a cutout in Little Compton there. It's a nice big out of some glacial till soils there. And you can see some granitic clasts that are kind of got plucked up as the glacier was coming down. And this is just the soil that formed on bedrock. There's a lot of bedrock in the Northwest Hills. Anytime you're driving through a highway, you see all this rock outcrop. We have shallow to bedrock soils. So that's another thing. When you hit bedrock, we call that an R horizon. This is a unique soil out in southeastern Mass. You'll see layers of organic and sand layer. And this is what you would find if you dig in a cranberry bog. And that's because they sand these every 4 or 5 years, and they add a layer of sand to the soils. So again, just showing you some different soils there. When you get into a wet soil, you'll notice the soils have very dark black, mucky material, and then there's none of that nice yellowish brown subsoil. It's just black and gray. That's indicative of a wetland type soil. We're looking at one of those today. We also have a lot of alluvial soils. This is if you were to dig along the Connecticut River Valley, you will notice a buried A horizon. That's telling you there used to be a surface there. A flooding event came and deposited some recent material on top. Again, great soils for agriculture. I don't know if I'd want to put a house on here because this is telling me this is a very dynamic soil, and it's probably going to, if it flooded once before, odds are it's going to flood again in the future. We also noticed some cultural features in here. That's a buried 18th century farmhouse that I did some work on there. A lot of fill, human transported material. We'll be talking a little bit about that. The focus of the Envirothon is urban trees, so they'll probably be asking a lot of questions about urban type soils. And again, one of the good things about looking at soils is it records the past history that's occurred in this soil. So when I look at this horizon here, I see a nice buried, what I could identify as a buried hydric soil. We got our black A and then gray colors underneath. And then on top of that is some mineral material, and that's fill from humans coming in and filling a wetland, basically. So that could actually be what's called a wetland violation, when somebody's gone in and filled the wetland and gotten into some trouble there. We do map soils underwater in Rhode Island. We call them subaqueous soils. This is one of my favorite profiles here on the left because what it basically shows is about 4 major geologic events that occurred from about 14,000 years ago right up to the present. So at the bottom is glacial till material. The next layer up and through here is loess. It's a windblown deposit. Then we get a freshwater. It used to be an Atlantic white cedar swamp, freshwater cedar material, and then on top of that is marine mud, basically, marine silts. So this shows you that it was a glacial till soil originally. Freshwater levels rose, formed a peat bog, and then sea level rose and inundated, and we have marine deposits there. So that's out on in Point Judith Pond in about 5 feet of water. We got that core there, and so we map soils underwater here in Rhode Island, which is pretty unique for the country there. Any questions on that? That's just a quick overview on some soil profiles, and now we're going to go into how these actually form. Let me pull this up. Yep, question? Yep. The question is, why do plowed soils have that thicker A horizon? It's basically a human modification to the soil. When the soils were first cleared and farmed, basically they were plowing the material up, adding organic material, which is manure probably, and building that surface. So again, usually if your surface, your A horizon is less than about 2 inches, it's never been plowed. And very difficult to find in southern New England. Most of the area was actually farmed and plowed. So we'll even find plow layers in forests with huge trees on it and steep areas and stony. You dig a hole and it's amazing that somebody plowed it at one time. So it's just a practice by the farmers to plow in the surface material, build up the surface layer. Yeah. Yeah, it's very actually hard to not find this plow layer in the soil. So I'm going to focus again on the Envirothon section of the soil section of the Envirothon there. My contact info is here. I'm sure all your teachers have info there. My website is NESoil, newenglandsoil.com. So if you're ever looking for soils info, go there. You can get my email and everything like that. So for the pit, for the contest, we'll basically have a soil pit dug out. Hopefully it'll be a backhoe pit. Some years we don't have a backhoe, but we'll have a pit where you're going to be asked to describe the soils, key it out, and then there'll also be some multiple choice, true and false, using a soil survey, measuring slopes. So we're going to try to cover everything we did. Always have to talk about the agency I work for. That's how I get paid for coming here. I work with the U.S. Department of Agriculture. We're responsible for mapping the nation's soil resources and providing information about the soils. That's just what I do. We have a whole other group that does conservation planning. We have engineers. We employ a wide array of different people. We got started in 1935 as the Soil Conservation Service. Our founding father was Hugh Hammond Bennett. He was the father of modern day soil conservation. In 96 or so, government got reinvented and we went from being the Soil Conservation Service to the Natural Resources Conservation Service. Still the same agency, we just changed our name kind of. The reason why we got started was in the 1930s, there was a Dust Bowl era. If you Google the Dust Bowl, you'll find out all the kind of information about that. It's a time when the nation's soil was basically being blown off, removed, and a lot of the really prime farmland areas were becoming, loss of their good soil material. So the Soil Conservation Service was basically established to address this issue, and not just soil erosion, but water erosion, and anything dealing with natural resources, mainly on farms, but we work with anybody that's interested in conserving soil and water. So our goal here is high quality productive soils, clean and abundant water, healthy plants, energy supply. We basically provide technical and financial assistance to private landowners. That's one of the major difference between USDA and NRCS is that we actually work with private individuals, whereas most other federal agencies only work on federal lands. So we're actually able to work with the towns, anybody, again, that's interested in conserving. So I mentioned this for the competition. There's going to be multiple fill-in choice questions on a test you'll have. So you want to review all the material that's online. We're going to break into groups. One group is going to be describing a soil pit, documenting the horizons, the color, and the texture, and then making interpretations about the soil. We'll probably ask you, does this soil have a high water table? Has this soil ever been plowed? Is this soil good for agriculture or trees? So again, anything like that could come up in the test there. We'll have a copy of the printed Rhode Island Soil Survey, which is, if any schools do need these, I should have bought a box of them. We're trying to get rid of them. Let me know, but you want to become familiar with using that. I think most of the schools have a packet of info. Again, anything you're missing, let me know there. We might even have it set up electronically, depending on where we are, where we ask you to use the web soil survey. So you want to become familiar with using that.